Welcome to my channel. Today in this video we are going to discuss about Malloc, calloc, realloc and free in C programming. Memory allocation, there are two methods. One is static memory allocation, another is a dynamic memory allocation. Allocation is in the hands of the programmer. STA is a fixed memory size, and in case of dynamic memory access allocation, the size may be varied, or you can say it may be changed. Static memory allocation versus dynamic memory allocation, it is a fixed size whereas it is a variable, and it is implemented using a stack. It is implemented using heap. It is a less efficient, and dynamic memory allocation is more efficient. There is no memory reusability, but here reusability is possible. Faster execution, slower execution, and these are some of the comparison between the static memory allocation and dynamic memory allocation. Stack and a heap. Stack is used for a static memory allocation and a heap for dynamic memory allocation. Both are a part of a RAM only. And the lowest address where usually OS will be used, and highest address in between. Here we have a stack and we have a heap. Dynamic memory, it is the heap. Static memory, so we use a stack area. Stack versus a heap. High speed access, it's a slower compared to stack, and limit on stack size depends on OS. It does not have a specific limit. Variables cannot be resized. Variables can be resized. Already once we have discussed the comparison static and dynamic, the same comparison may come here also. Faster access and it is a slower access, and handled by computer compiler, but it is handled by the programmer. Heap, when to use? When you require to allocate a large block of memory, we prefer heap. Otherwise, if a small variables are there, then we prefer stack. It is an example how to use a stack area, heap area. So you are declaring an integer a, one array, and you are assigning n value as a 20, declaring as a int. So these are all stack. Heap, you use a pointer. So when you use a pointer, it will be allocated in the heap. And C language offers 4 dynamic memory allocation functions. Malloc, calloc for allocating a block of memory, and to alter the size of this allocated block we use a realloc, and to deallocate this block of memory we use a free. These are the 4 functions available in the C language. Malloc, a number into size of int float. This is a syntax. Calloc, number comma size of int or float. Here it is only one term. Here we have a 2. Realloc, pointer name and how much you want size. And free, simply the pointer name we give it. Malloc function is used to allocate a space in the memory during the execution of the program. It does not initialize after the allocation. Some garbage will be stored in those locations. It returns a null pointer if fails. If does not allocate any memory, then it will return the null pointer. And let us see the size of the int, float, double and character. So one small program executed, and the answer's size of a int is 4 byte, and size of a float is a 4 byte, size of a double type is a 8 byte, and character is a 1 byte. And usually percentage LD we use for a long int. Pointer, malloc n into size of int I want for integer. Therefore I have to do the typecast. Then I'll assign, because it gives a generic pointer. Now n is an unsigned int for a positive number only, always n. The malloc returns the white pointer. Hence I need this. Pointer gives the address of the first byte of the block. And it is best practice, rather than writing a malloc 20, we can write n into size of whether you want int or float. It's a small program using a malloc. Pause it, read it once. Again, the same pointer equal to I have used. If pointer becomes null, then memory is not allocated. This program we are going to use throughout this discussion. Please pause it and read it once. And next, if pointer is not null means memory is allocated. Here, the elements of the array are, I am assigning in the loop. What I am assigning? Pointer of I. That location I am simply assigning 1, 2, 3, 4. Let me see the output. Yeah. So enter the number of elements 5. Memory successfully allocated using a malloc. The elements of the array are 1, 2, 3, 4, 5. Now, how to see the addresses? Where it has stored? For that, see this program. This slide will remain same. Now, only this I have changed. What are the changes? Instead of pointer of I am including this particular ampersand pointer of I. Instead of percentage %d, now percentage %p I am writing. This is only one line change. So that I will see the addresses as well as its content. See this. Now addresses are there. Now you can see the content also. Size of the pointer is usually equal to size of the integer equal to, now it's a 4 byte. You can count number of bytes. What might be the content of the memory locations before assigning some values after malloc? The same program, what I am doing, simply I am displaying the content of that memory before assigning the values. After assigning also I am printing the result. Before assigning, garbage is there, some numbers are there. After assigning, I have a numbers. Addresses are same, 84, 88, 8C, see the same addresses. The before, some garbage is there. After that, whatever I am assigning, values I can see. Calloc. Calloc, it is like a malloc. Only the difference is it initializes the allocated memory to 0. Used where the initialization is necessary. For example, you are creating a database to store the bank balance of all the customers. It is better to have a 0 when you initialize it. Otherwise, sometimes some random number garbage is there, that becomes a dangerous. Now, the same program, instead of malloc, a small change is there. You have made it as a calloc. The remaining we have kept as it is, same program. Now, the difference is, as soon as you use a calloc, this content are initialized to 0. Earlier case it was a garbage. Now it is initialized to 0. And after the assignment, whatever I am assigning, that is stored in the memory. Realloc function modify the allocated memory size. You can increase or you can decrease. Pointer format is pointer equal to realloc pointer comma x. Now the size becomes x. X may be more compared to the previous or maybe less. If a memory is not sufficient for malloc or calloc, you can reallocate the memory by realloc function. In short, it changes the memory size. It's the same program. Calloc I have used. Instead of now, whatever the length was there n, I'll increase it plus 3. Again, I'll use a realloc. Now, instead of n into size of int, I'll make n2 into size of int. So that reallocation, number of location needed is more. Simply I have printed. Because I used a calloc, all are initialized to 0. After assignment, it is numbers are assigned 1, 2, 3, 4. Now realloc I have done, but it has not changed the addresses. So remaining additional locations are given, that's all. Sometimes it may change, it may not change, depending upon the number of additional locations you want. Free. The memory allocated using function malloc calloc is not deallocated on their own. Free method in C used to dynamically deallocate the memory. But remember, pointer will not be deleted or not destroyed. Free function frees the allocated memory done by these malloc calloc as well as realloc. This is same program. Now after execution of the program, calloc, all these printed, last I'm doing free pointer. Again I'm trying to check after free what will be there. Let us see the program. You can pause and see it once. I'll show you the result next slide. See, calloc all are initialized to 0. I assign some number. After the pointer is freed, remember the content will not remain same. Once if you free it, it is dangerous to use the pointer because pointer will be there, it will not be destroyed, but content will be not same. This is a very important point which you have to remember. This is the same point. Calloc all are initialized. Again I have assigned, and here reallocation I have done, and then I have done free. I have freed, but location content are changed. Thank you for watching this video. These are the references, and for more information you can visit these links. And if you like video, please share with your friends and please subscribe. Thank you.